Hello everyone. Welcome back Primary 5 Superheroes. This is Amazing Science with Mr. Seif. Today I have a great challenge for you at the beginning of our session, and let's get started. In front of you here, find 10 hidden objects in this picture challenge. In this challenge, we need to be looking for these items. We are searching for these items here. So would you help me in finding them? I guess you can see the sandwich here. Perfect. So we finished this one. You might be looking for the duck, and it's found here. I found it. The next one going to be the pizza. Do you know where's the pizza? It's here. Perfect. So let's cancel it. What about the watermelon? I guess the watermelon is obviously found there, here in this area. Okay, the following one, you mean this one? The water droplet that looks like the fish? We found it. The turtle is really hard, but you are genius to find it there. Perfect. We're still looking for the butterfly. So where's the butterfly? You might be looking for the maximum right-hand side at the top of the screen there. To find it here. Perfect. Okay, the fish bone. Do you see it? I know it's really hard, but I can see it here. Perfect. The last two items, the ice cream and the bone. I can see the bone. It's here. It makes sense. A dog is playing with the bone. The ice cream, I guess that was the hardest one, but I can find it here in this area. Thank you so much. You did a great job in this challenge. And actually our today's topic going to be something related to this challenge. Or to be specific, our today's topic going to be talking about all items around. Everything or anything around, not just these items. So our today's topic going to be the matter. What does it mean, matter? Matter means these items or other items. What I'm trying to say, matter means everything or anything around. So in this lesson, we're going to be studying the matter, the states of matter, and finally properties of matter. Let's get started. And now with the second challenge that I have for you. In front of you here, some flashcards represent everything or anything in 3 different states. So these flashcards for some objects around, they could be classified into gas, liquid, or even solid. So let's try to classify them together. I'm going to start by the first one, the aisle. The aisle. Do you think the aisle is a solid or liquid or gas? Just think with me. And it's okay, even if you made a mistake, we can correct it later on. But the aisle, like the water, both of them are liquid. The second one here going to be the hydrogen. The hydrogen, it's a gas found around us in the atmosphere. So it's going to be a gas. The following one here, wood. And I guess you catch it correctly. The wood going to be classified as a solid. The following one going to be rocks. The rocks, like the pieces of wood, both of them are solid. The next one, paper, it belongs to the same category. And the next one that we have here, water vapor, it's going to be gas. Okay, the following one, oxygen. I guess that's a common gas we breathe. Oxygen going to be gas here. The milk. How amazing you are. The milk belongs to the liquid category. The carbon dioxide. Okay, the carbon dioxide represented by a balloon contains gases here. So it's going to be a gas. The ice cube. Kindly keep in mind, this is a tricky one. I know the ice cube is made up of water, but this kind of material in the current situation found in a solid state. I know the water normally or generally is found in a liquid state. But is it the current state right now? I guess it's not the current state. The current state right now for the ice cube going to be solid. And then the rain, which represents a liquid. The final one going to be the water. So all of these objects are found around us as examples of 3 states of matter. We have solid matter, we have liquid matter, and we have gas matter. What are the main differences between solid, liquid, and gas? Look here. Any difference between them could be a correct answer. For example, I guess they are different in colors. Yes, all matter different in colors. They are not all the same color. The second one that I have for you here is the size. Do you think all matter are represented by the same size? I guess no, they are different in their sizes. Do you think they are the same shape or have different shapes? The hardness. Some of them are really hard, some of them are soft, even the temperature. So our question's going to be like that. Give reason for. I need you just to think with me about the correct answer. However, is it correct or not correct? It's going to be shown there to make sure, but just think with me. The first question that I have for you, give reason for. Wood differs from the water. Just think about the reason. What makes the wood different material? What makes the water different material? What differentiates between them? What are the differences between wood and water? If you said wood is a solid, water is a liquid, that's correct answer. So let's check another question. Milk differs from the oil. So give me a reason. Why oil differs from the milk? What is the difference between them? Both of them are liquid. I guess you might be looking for them to determine the difference in the color. So if your answer was because the oil has different color, that's correct. Or even if you said the milk has different color, that's correct. Both are different colors. The next question going to be a little tricky question. What is the difference between vapor and rain? So give me reason. I need you to think with me. Give reason for. Rain differs from the water vapor. Why do you think? What makes them different? Both of them are water. You mean the temperature? You mean the water vapor or the steam that exits the kettle there differs from the rain because they have two different temperatures? Yes. So the vapor is hot and the rain is a little cold comparing to the water vapor or the steam temperature. So they have different temperature. The following one going to be the ice cube and the wood. What do you think is the main difference between them? Think with me. They are different. So the question going to be give reason for. Ice cube differs from wood, or differs from rock, or differs from paper. I know we have many differences, but you might be mentioning the size. They don't have the same size. Some of them are large and some of them are small. So this is how to answer this kind of questions. I know you catch it correctly, so thank you so much for your effort in this exercise. And now let's submit our answers to discover our score. It seems like all of them are correct answers. Give yourself a big hand and see you in the upcoming exercises. Welcome back. Although the states of matter are different in the shape, the color, the size, the temperature, even in the hardness, but the essential difference that is found between them all in the state itself. What makes solids solids? What makes liquids liquids? And what keeps the gases like that? Actually, the particles. Every state of the matter is made up of tiny particles or small particles, as you see there. So the particle is the basic unit of building up the matter, or the unit that builds up the matter. So the solid state is made up of small particles, the liquid state is made up of small particles, the gaseous state is made up of small particles, but it seems like we have many differences between these particles. How do they behave? Because actually their behavior and how do they move, how do they act, what makes every state of matter different like that. So let's discover how do they detect and determine the properties of each one of them. Let's start by the solid, and here we go. Here we go. In front of you here a simulator for the particles of the solid, liquid and gas. Let's start by the solid. In the solid state, we can see the particles are very close to each other, like exactly what do you see here. The particles are moving, but they cannot move freely. So they move, but because they are very close to each other, almost there are no spaces between them to move freely. So that's what makes the solid stay solid. The particles are very close, almost. There are no spaces between the particles. They have a kinetic energy, but it's not that much energy. They are slowly moving because actually there are no spaces. What do you see here determines the properties of the solid state. It makes the solid state has definite shape, so the shape of the solid will be definite. It's not changing by changing the location of the solid. So when you take a solid from a place to another place, it stays the same because the particles are not moving away from each other. They are detected or determined by a shape. They have a specific shape. They don't have spaces to move, so their shape is not changing. Also the volume, look here. The volume of the particles almost the same. Is not changing even if we change the location of the solid from place to another. The solid state stays solid with the same shape, with the same volume everywhere. So from what we have studied just right now, the solid state has definite shape. Definite means the shape is not changing from place to another. Their shape is not changing. So definite means fixed or constant shape. It's not changing by changing the location or by changing the container that we put the solids in. Also the volume. The volume of the solid state, if they are solid state, is not changing because they have specific dimensions. The particles here are very close, so they are not moving freely, so they don't have a space to change their volume or to change their dimensions. They stay with definite shape and definite volume. Right now the turn comes for the liquids. The liquids actually are made up of small particles as well. As we mentioned before, the particles are making up the three states of matter. But they have something different here in liquids. Would you just mention what is the difference? Can you differentiate between the particles of the liquid and the particles of the solid? I guess the solid is more organized, but the liquid are a little moving. They are moving away. And I guess the spaces in the liquid is larger than the spaces in the solid state. Why not to discover that by ourselves? Let's go in. We need to go right now to visit liquids. Let's go in. In front of you here, the particles of the liquid. Look and tell me, how do they behave? How do they act? It seems like they are moving faster than the particles of the solid. So they have more kinetic energy. They are moving faster. So the particles are moving more freely than the solid. Here the particles have larger space and more kinetic energy. This is why they are moving faster and they go away around the dimensions of the container. What do you see right now makes the liquid state takes the shape of the container. How does this happen? Let's go watch it. The liquid examples here in front of you are water, oil, and milk. So we have three different liquids in front of you. Look at the water. When we pour the water in the cup, it takes the internal shape of the cup. It takes the shape of the container. It might be in the water only, Mr. Seif. Okay, let's watch another liquid. Here is the oil. Look, the oil takes the internal shape of the container. Maybe because that's an exception in oil and water. Okay, let's watch milk. It seems like when we pour the milk from this bottle, look here, the milk inside the bottle takes the shape of the bottle. When we pour the milk inside different container, it takes the same shape of the cup. Okay, let's watch the same liquid in more than one container and then determine. Here we go. What do you see in front of you right now is an orange juice. It's poured in three different containers. Look and tell me, look at the dimensions here of the container and the shape of the orange juice. It seems like the orange juice takes this shape, the same shape of the container. When we pour the orange juice into a different cup, look at the shape that it's going to be for the orange juice. Is that the same shape of that? Are they the same or different shapes? Perfect, they have different shapes. Okay, let's put it into another container. It takes a new shape. The orange juice here takes a new shape of a new container. So it seems like the liquid shape is changing by changing the container. Why does this happen? Because it could be an answer for one of the important give reason for questions. The shape of the liquid state is changing by changing the container because the particles of the liquid are a little away from each other. They have more kinetic energy, so they are moving freely. This is why they take the shape of the container. So we can determine that the liquid shape is indefinite. The word indefinite refers to is not the same. It refers to something is not the same, is changing by changing the container. So as you see here, different liquids in different flasks, in different containers, and every liquid takes the internal shape of the container right now. So the liquid state has indefinite shape. The shape of the liquid is changing by changing the container. What about the volume? I guess the volume here going to be determined by this experiment. Can you just look here and tell me how many milliliters of water do we have in this beaker? Okay, it seems like we have 100 milliliters. Okay, would you look here and tell me how many milliliters of water do we have? Almost the same, 100 milliliters. Okay, and here, how many milliliters do we have? Perfect, we have also 100. So, did you notice something? First of all, look at the shape. Are they the same shape? The liquid inside is not the same shape. So, they have indefinite shape. We determined that. But the volume of the same amount. Here, it's 100 milliliters of water. When we pour it into a different container, it takes a new shape, but the volume stays the same. And here, in the last one, when we pour the liquid in a new container, the third container gives the liquid inside a new shape, but it doesn't give it a new volume. So the volume is 100, 100, 100 in all the containers. 100 milliliters, 100 milliliters, 100 milliliters in 3 different containers. Although they have different shapes, but they have definite volume. The volume of the liquid state is not changing by changing the container. They have definite volume, but they have indefinite shape, because actually the particles here cannot be compressed. The particles are the same. Maybe they are moving. So the particles of the liquid are moving to take different shape. So they have indefinite shape because the particles are away from each other. They have spaces between them, and the particles are moving freely with extra amount of kinetic energy than the solid. So they have more kinetic energy, more spaces, they are moving to take different shapes. But in the volume here, the particles are not increasing or decreasing or even compressed. They have definite volume. The volume of the liquid cannot be changed by changing the container. The turn comes right now for the gas. And now I guess, our next step going to be in the simulator. Let's go in. Now we need to visit the gas. Let's go in. Here are the particles of gas. Look and tell me, how do they behave? How do they act? First of all, you need to describe the motion. Are they moving slowly or quickly? I guess they are moving so fast. So they have extra amount of kinetic energy. They have high amount of kinetic energy. So that's the first thing in the properties of the particles of the gaseous state. Even the volume of the gas. Look here. Do they have a specific volume? When particles are moving away from each other quickly, so they have extra kinetic energy. And they have large spaces between them. Look here. They have more kinetic energy than the liquid, even the solid. And they have more spaces, more than the liquid and more than the solid. So here the particles of the gas are moving quickly, so fast, and they have extra large spaces between them. That's what gives them indefinite shape. It seems like the gaseous state has indefinite shape because of the motion of the particles. The particles are moving freely, so fast, so they don't have a specific shape or even the volume. Because actually these particles have extra kinetic energy. Just think about what's gonna happen if we reduced their motion. If we reduce the kinetic energy of the gaseous state, what happens to them? So think about this question until we summarize the properties of gas. This is why the gaseous state looks like that. It has no specific shape. It takes any shape of any container around. It takes the shape of the container inside, and when it comes out, it takes indefinite shape. It takes the container shape from inside, but when it comes out, it takes indefinite shape. So the gaseous state has indefinite shape. What about the volume? It seems like the gaseous state volume, what is that? The volume was the same volume of the balloon inside. Look here, it has the same volume of the balloon, but right now it takes different volume. Look here, in this balloon, it was small, but when we fill it with gases, when we blow the balloon up, it takes larger volume. So it seems like the volume of the gaseous state is changing. And this is why the gaseous state, it's the only state can be compressed. And that's why we can use it in making balloons like that. The gaseous state has indefinite shape and indefinite volume, and it's the only state of the matter that can be compressed, because actually they have large spaces between the molecules, so we can press them and get them closer to each other, so the shape and the volume together are changing in the gaseous state. So now let's summarize the properties of each state of matter here. The properties is written behind each flashcard. You need just to determine them correctly. First of all, the solid state has two main properties. Would you just expect what are they? I guess you can remember them correctly. The solid state has two main properties: definite shape and definite volume. And right now the turn comes for the liquid state. Can you remember the properties of the liquid state from what we have studied? You mean they have indefinite shape and definite volume? If your answer was like this, that's correct answer. And finally, the gaseous state. And I guess you can remember the gaseous state properties correctly. They have indefinite shape, indefinite volume. And right now we have a nice exercise. Let's do it together. First of all, you might see a question here or in this empty area about one of the objects that will be here in this empty area. The answers will be there. So you need to pick up the correct answer of this question. Here we go. A wooden chair. Is it solid, liquid, or gas? I guess your answer is solid. Perfect. Let's go to the next one. Here the question is a little tricky. The bubbles in the lemonade or in the lemon juice, the bubbles there, do they represent? I guess you maybe think it's liquid or gas. But here is a problem here. We are asking about bubbles. I'm not asking about the liquid. So I'm asking about the gaseous state. Perfect. Let's move to the next one. The orange juice. That's an easy question. It's gonna be liquid. The following one going to be the tomato sauce. Is it solid or liquid or gas? Kindly keep in mind, I'm not asking about the package. I'm asking about the sauce inside. So I guess the sauce inside takes the same shape of the package. It takes the same shape of the container. So it's gonna be liquid. Perfect. The next one here, a block of chocolate. A block of chocolate. You mean solid. Perfect. This is the last question in this activity. A helium inside the balloon. Kindly keep in mind, the helium is the gas inside. Oh no, I have answered. So the answer here is going to be the gaseous state.